Hello and welcome. My name is Pascal Seifert and I'm the Technical Product Manager for VRED. With VRED 2022, we have introduced texture-based light maps for ambient occlusion, shadows, and light and shadows including direct and indirect light, caustics as well as IES and ray light profiles. This offers new possibilities and use cases to the fact it is now possible to bake high-quality results on low-polygon objects without subdividing meshes. Keep in mind that data baked into a light map cannot change at runtime. Of course, real-time lights can be overlaid and used on top of light map scenes, but cannot interactively change the light map themselves. It is possible to calculate texture-based light maps with CPU or GPU ray tracing using NVIDIA optics and use VRED cluster to distribute the calculation of light maps on multiple machines. Meshes you want to calculate light maps for must have proper UVs. Ideally, using the maximum available UV space, have less as possible distortion and less as possible disconnected UV islands with enough space in between for an edge dilation necessary for light map textures. The changes we did to our UV editor recently comes with all the necessary tools for creating proper light map UVs, and it's not necessary to go into any DCC application. It is possible to combine vertex shadows with texture-based light maps in one VRED scene, and users can toggle the behavior either in the Scene Graph context menu or the combo box in the Advanced tab of the Bake Light and Shadow module. To better judge the baked results in the scene, users can toggle between the different visualization modes, realistic, ambient occlusion, and pre-computed illumination, in the visualization menu, or double-check the light map texture directly in the UV editor. So let me quickly summarize the pros and cons for vertex shadows and texture-based light maps. Vertex shadows are fast to calculate and require no additional preparation time. Also, the memory consumption is very low due to the fact the information is stored just for the vertices of each geometry. On the other hand, the quality is dependent on the amount of vertices and sometimes requires a very high tessellation to get a decent quality for your shadows. Of course, it is possible to subdivide geometry only in areas where more information is necessary, but this adds more triangles to your meshes and makes following processes like unwrapping more complex. The texture-based approach is tessellation independent, and the quality of your light map is dependent on the texture resolution and UV map. They can be calculated with CPU or GPU ray tracing and even be clustered to speed up the calculation time. Also, clones can now have individual light maps, and it's not necessary to unshare geometry if a pod is used at multiple places in the scene. Also, the texture-based pod of the light and shadow module is decoupled and comes with a modern API. The downside for texture-based light maps is that they require more graphic card memory and your scenes get bigger as more light maps you have in your scene. Proper UVs are key for having high-quality light maps and might require additional preparation work. So in this video we will talk about how to create proper UVs for your light maps, as they are crucial for the quality at the end. I have different objects with different complexity in my scene, and I will share some best practices on how to unfold them correctly. I will also calculate some ambient occlusion from time to time, but I will not explain the module further, as this will be part of a second video. So let's start very simple with that cube over here. In our UV editor, we have introduced a second UV set for light maps. The material and the light map UV set can have independent layouts. To unfold that cube, you can press unfold and layout. As you can see, that layout is not really sufficient, as it shows just one side of that cube and all other 5 sides will get the same texture. So that means we have to cut that cube apart. So this can be either done by an edge selection and then cut edges, or you can also proceed a triplanar mapping on that cube and layout it afterwards. So now you can see all 6 sides. The goal of a light map UV is to fill out the maximum available UV space and have less as possible islands that are connected to each other. We also need some padding between the islands for what we call an edge dilation later. So in your layout settings, in island distribution settings, you can set a value of 0.02 and do the layout again. So this gives us some space between the islands. You can also now sew islands together to connect the borders. But for our cube, I think this is sufficient enough. So let's calculate some ambient occlusion for that. In the Bake Light and Shadow module, I choose Bake Type Texture. I want to use my GPUs. I calculate a simple ambient occlusion. I use some denoising. Very standard settings. In the Advanced tab of the module, you can see your light maps as a preview. But it's also possible to enable Show Texture in the UV editor. Here you can see the 2 pixel edge dilation between the islands. So our next example is a little bit more complicated, and the triplanar mapping would be probably not sufficient enough, as this gives many small disconnected islands that will get only 1 pixel in the light map. As you can see, there is only 1 or 0 pixel for some of the islands, which will end up in some black parts. Also, the edges don't look very good. So let's delete the light map and start from scratch. So I can sew all the islands and unfold and layout them again. And now when I enable the wireframe, I can start selecting the edges I want to cut later manually. That looks pretty good, and if I want, I also can connect that single island with all my others. So now I have only a few cuts in my UV layout. So let's calculate the ambient occlusion again with the same settings. There are still some edges visible. The only way to work around that is getting a higher quality or a larger light map. The light map is 466 by 466 pixels now. If I would change that value to something higher, of course my calculation time increases, but also the quality of my light map gets better. So for the next object, I'd like to show you one of our latest implementation that can be found in the UV editor under Edge Selection and is called Automatic Seam Selection. So there are different algorithms here in the drop-down, and it's a little bit playing with the settings to find out what it's actually doing. So in our case, I take the manufacturing mode, and then I select and I see nothing happens. But as soon as I change the area ratio and select again, you see that I get some pretty nice cuts or selections for my spiral object. Now I can cut them and unfold and layout that again. Also in my layout settings I can change, for example, to a horizontal layout, and that makes it a little bit easier to introduce more cuts. So we are not filling out the maximum available space here, and I think I would introduce some more cuts, even if they could be seen at the end on my object. But on the other side I use more pixels for my light map here. So let's cut that here and unfold and layout again, and you see we are using half of that. So I think I would even introduce more cuts until I fill out the maximum space. Let's see how it looks after the calculation. So on the next object, I'd like to show you how you can copy over UVs from your material set to your Lightmap UV set. That object is NURBS data. And on import, we create for each surface a UV island that can be used on the Lightmap UV set further. So go to your material UV set and then copy that to Lightmap. On your Lightmap UV set, you can proceed a simple unfold and layout. Here you see that for each surface on my NURBS data, I have an island available. And the only thing I have to do is to sew those together. I think I will get the best results when unfolding them. So in my case, I can go to the island selection mode and then start simply picking those I think that belong together, and I'd like to split the front faces from the back side. Therefore I change my or disable the use depth selection in my selection mode, and then I can simply drag a box and select the islands I want to. That's actually pretty quick and one of the benefits when working with NURBS data. So once I have collected all the islands, I sew them together and can proceed and unfold and layout again. And then I simply move the one that is sewed together away and pick all the other islands and then proceed the unfold and layout again. This gives a pretty nice layout for my chair. I will not unfold the legs of the chair now, because there is another nice option in the Bake Light and Shadow module that does a triplanar mapping and layout for all objects that are not unfolded yet. So I can select the whole chair, enable the use existing light map for my UV sets, which I have created, and do a triplanar and layout for my legs. As you can see, the layout for my legs does not look that good, but I think it works for now. So the next object is actually pretty easy to unfold. This is a wire import from Alias and not a solid body, so it does not have any backsides. I can simply select the whole wheel and do an unfold and layout. And then check my layouts. The tire could actually need some manual work, due to the fact that on my UV set, this side, which is the inner ring, will get less pixels than the other side, and I'd like to have a homogeneous distribution of the pixels. So I will simply introduce some cuts to unfold them a little bit better. As I'm not using the maximum available UV space, I will introduce some more cuts here. I could simply do that by edge selection and select shortest edge path, and then select one vertex here and the other here and do a cut and see what it gives me. And this is actually quite nice. So then let's simply calculate some lights. So one benefit for texture-based light maps is that clones can have individual light maps, and it's not necessary to unshare geometry in my scene if the pod is used multiple times, like it was necessary for the vertex-based approach. My screw here is a clone object and used multiple times in my scene, but can have an individual light map. So let's simply copy all my UV islands from the material to the Lightmap UV set. And then unfold and layer them. So this is not a really good Lightmap UV, but sufficient for our case here. So in the Bake Light and Shadow module, there is an option called Share Lightmaps for Clones. And this is really helpful if you have an object like a car that is mirrored from the right to the left side. But in that case, we want to do the opposite, and we want to create a light map for each of these clones. So here you can see that each of the screw, even if it is a clone, has a different light map. And you have seen that there has been 17 light maps being created. If this option would be enabled, you see VRED calculates only 10 light maps. And each light map would be identical, which is wrong in that case. Last but not least, let's have a look at data in the Opability and what happens to my UV maps when exchanging data via FBX with other DCC tools. So my geometry has two material UV sets, two different layouts. For my material UV set, the arrow is facing upward. For my light map UV set, the arrow is facing to the right. So let's export the geometry via FBX to my desktop. And let's import that geometry into Maya. So as you can see, it kept the material and the Lightmap UV set and also its naming. And when you export that geometry again and import it again into VRED, the UV sets are kept. So what if you have a geometry with multiple UV sets and you want to take a certain one for your material and Lightmap UVs in VRED? So you actually can name any of these set like a channel you want to have it in VRED. So let's take UV set 3 and call it material UV set, and take UV set which is facing downwards and take the UV set 4 which is facing to the left and rename that into Lightmap. And let's export that geometry as an FBX again. and import that one into VRED. So as you can see, for the material UV set, it has chosen the UV set from Maya by name, which was the UV set 4, and made it the material UV set. And the Lightmap UV set is the one that is facing to the left. Thanks for watching and see you in the next video.